Hi folks, in this video we discuss how to do formal proofs with the conditionals. Specifically, we're going to look at arrow elim. Remember how modus ponens works in informal proofs. If you have if p then q and you also have p, then you get to infer q. And arrow elim works the exact same way because our elim rules apply, remember, to places where we already have that symbol. So if I have a premise with an arrow and I have that antecedent, then I get to infer the consequent on its own line. And what you cite is those two lines. Biconditional elim works the exact same way. And in formal proofs, doing formal proofs with the conditionals, the biconditional rules are really going to be just reproductions of the conditional rules, because really a biconditional is just two conditionals. So I can do arrow elim going one direction, like if I have p and p biconditional q. Or the nice thing about the biconditional is if I've got line 1 and q, I can also go in the other direction. So the biconditional just allows you to do modus ponens in either direction. The only thing you have to be careful of is remember to cite biconditional elim, because you have to actually pay attention to which is the actual symbol that you have. Okay, now if you've got those rules, you should be able to do some proofs with them. So pause your videos now and see if you can figure this proof out. Okay, that was your chance to pause your videos. Now, notice this is a really good proof because this shows how everything you've learned with Boolean logic applies now. If you didn't master doing formal proofs with the Boolean connectives, you might have no idea what to do here. So that's the way in which this course is just going to keep building on itself. And if this is not familiar to you, then you need to go back and start reviewing now. There's still time. There's still time left in the quarter. But if this is a challenge, this is a check for you, a comprehension check that you need to be doing some more review. Because what should you have done first here? Well, hopefully you looked at the main connectives and you saw that your main connective of your premise is an arrow. Now you might have been tempted to do some modus ponens on it, bring down P or bring down Q, but you cannot do modus ponens unless you also have the antecedent. You can't do arrow elim with an arrow alone. It's not like a conjunction. You need to have P somewhere. You might have assumed P, but that's actually a trap. Whenever you have an arrow, don't just assume the antecedent. That's usually not a helpful thing to do, at least not directly. Instead, you should have looked at the main premise, the main connective of your conclusion. That tells us what to do. This is a wide scope negation, so that tells me I should do a reductio. This is the proof that I sketch out. And now once that I'm here, it's much more obvious what we should be doing. I've got a wide scope conjunction. So again, the main connective is telling me to bring down those conjuncts. Now, P has appeared, but it's not because I just assumed it. That would have been a dead end. I've earned my right to P inside this reductio because I got that conjunction. Now that I have this, I can do arrow elim. So I just cite line 1 and line 3, and that's how I get Q down here. Now that I have Q and not Q, it's clear to me how the reductio is going to end. That's going to be the basis of my contradiction. And once I have the contradiction symbol, don't do contradiction elim. Instead, you jump out of the subproof and do negation intro. So remember, why did I start this subproof? It's because I was going to do a reductio. It's not to do contradiction elim. It's because I want the contradiction, and I'm going to do negation intro with it. So there's your first proof using arrow elim. Thanks.